Hi, in this video lecture, we'll finish up with the veins and some special circulations. So the veins, we have, for instance, three very important systemic veins that are going to help us return blood to the heart. Can you think of one of them? Right, the heart is right over here. So there's one major vein going towards it and one major vein that's going from the bottom. Right, so those are at least two of them is superior vena cava and also the inferior vena cava. So what we're missing is the circulation from the heart, the coronary sinus. So these three veins, these three major ones, are going to help return blood back to the heart and then get them full with oxygens again. Now, so let's first take a look at the veins of the head and the neck. So if you take a look over here, now our blood from the head will drain eventually into three veins. So if you take a look over here, one of them is the internal jugular, and we're only looking at the right one, yeah? But of course, the left one is symmetrical. And if you take a look over here, you have the external jugular. And we have another one in between that runs in the vertebral part that drains right here. So this is your vertebral vein. Okay, so right internal jugular, right vertebral vein, and the right external jugular. So these three are going to help you drain the blood from the head and eventually back to what we call the right brachiocephalic vein. Now, unlike, for instance, the artery, we have only one brachiocephalic trunk, but there is two in the veins. We have the right as well as the left brachiocephalic veins. Now let's take a look at how they drain through it. So here is your superior vena cava. So you have your right and left brachiocephalic veins that drain into it. Now remember earlier we were talking about the internal jugular as well as the external jugular. The external jugular feeds drain into the subclavian vein, then together the internal jugular and the subclavian vein drains into the brachiocephalic vein. And here the vertebral vein drains into it as well. Okay, so pretty much it is symmetrical as we have seen. Now let's take a look at the veins of the upper limbs. We also have to drain all the blood back because now as they are deoxygenated, carrying waste and CO2, you have to move them back. Now these are the superficial veins. You will see the deep veins as well. Superficial veins, for instance, you can see a very prominent one, the median cubital. For this one is the right median cubital vein, and where you have the right basilic vein. On the other side is the right cephalic vein. Now, the median cuboidal vein is very, very important when it comes to, for instance, blood test or transfusion. This is usually the site where they will be taking blood samples, and for injection or so. Now, if you take a look over here, you can see, remember our muscles, the bicep brachii. Underneath, you can see the brachial part and brachial vein, the basilic vein, cephalic vein on the other side, and the median cuboidal vein. That's really easily accessible for blood testing. Now, here is another view of the deep veins now. So the deep veins, of course, runs deeper and it drains according to the region as well. We have the right radial vein, as well as the right ulna, right vein, and then it drains back into the right brachial. It's very similar to the artery version. And back into the armpit would be your right axillary and right subclavian, and back into the brachiocephalic vein and back into the superior vena cava. Okay, so make sure you know all of these ones. Okay. Now here is the scheme of drainage, just to show you again. So everything eventually from your right and left arm will drain into the superior vena cava. So the right brachiocephalic vein drains straight into it, but let's take a look at, for instance, what we saw before. Our right radial, right ulna drains into the right brachial. That drains into the right axillary, into the right subclavian. Now, we also saw earlier the median cuboidal vein. Yeah, that was in between the basilic and the cephalic vein. Now, ultimately, you have your right internal jugular together with the right subclavian. They drain into the right brachiocephalic vein. Okay, so make sure you know these and when you study for them. Now, let's take a look at the veins of the thorax. Now, are going to drain regions eventually back into your superior vena cava as well. So earlier what we saw was the upper part, okay, from the right upper trunk as well as the regions of the head. Now the azygote is going to be draining, for instance, region from the thorax. Now the azygote is right here running along the side of the vertebral column. So right next to it, this is on the right side, is your azygos. Azygos. Now we also have accessory hemiazygos. Those are the one on the top here, draining on the left upper portion of the body, and you have the hemizygos that drains from the lower half. Okay, and those drain the blood back into the azygos, and the azygos drain into the superior vena cava. Okay, so very important. We haven't seen this word before. Okay. Now let's take a look at the veins of the abdomen and the pelvis. Okay. Now, so let's take a look at either right or left side, but let's take a look at this time from the left. But pretty much we have our right common iliac vein, right common iliac vein. They have their respective external iliac, internal iliac that drains into the common iliac, and both right and left common iliac is going to drain back into inferior vena cava. And along the way, it's going to receive all the other drainage as well from lumbar, gonadal, and renal, suprarenal, hepatic, back from the liver, and, for instance, all the way back into the heart. And which part of the heart do they drain back into? Right, the right atrium of the heart. Okay, all right, so let's take a look over here to see them. So you can see the left femoral. Let's take a look at it. And then you have your left external iliac, and here is your left internal iliac. When they merge together, it becomes the left common iliac. The same thing for your right side as well. So your two right and left common iliac drain together. This is your inferior vena cava. Okay. And all these other ones, for instance, the gonadal veins, either testicular or ovarian veins, and you have your renal vein because your kidneys are right around here on the back side. Okay, suprarenal for the adrenal gland. Okay, and all the way back into the other portion of the vena cava and back into the heart. Okay. Now let's take a look at the veins of the lower limbs, and then we're almost done with the veins. So here is some of that we saw earlier. Okay, just want to show you as we continue, you have your right femoral vein that's running over here. Now this one in the front is a very, very long vein. This is our great saphenous vein. This is an anterior view of it. You can see it in the posterior view as well. The great saphenous vein is the longest vein. And also our this is the region where if you have any bypass graft and needed to take a section out from the vessels, this is that vein that they will be actually targeting, and then take a section out of it to put it somewhere else for a bypass surgery and grafting. Now also our lower limb, these veins are very highly subjected to the varicose veins, the varicosity, because a lot of pressure, and the veins don't work very well, especially if their valves are not working very well. So it is hard to pump the blood back into the heart. So a lot of times then blood tend to accumulate in the lower limbs, causing those varicose veins. So I want to make sure you know about that. And here is the scheme of drainage. And so the ones we've mentioned earlier, for instance, like the right femoral vein, and we also have the great saphenous vein that feeds into it, feeds into the external iliac, internal iliac, and both of them drains into the common iliac and back into the vena cava. All right, now some very special circulations. So we're going to take a look at our hepatic circulation, our pulmonary, as well as fetal ones. And let me change my pen back to blue, because since we're not coloring the veins anymore. So first we're going to take a look at our hepatic circulation. And when you think of hepatic, where does it lead you to? Right, our good old liver. Okay, so let's take a look at our hepatic portal circulation. So, and let's take a look at why we have to have hepatic portal circulation. And here's the reason. Now, you have all your goodies, okay, from your digestional tracts, okay, from your digestive system. Okay, so right now it's showing you all different parts of it. Could be from the stomach, pancreas, large intestine, but pretty much the overall is your digestive tract. They are going to absorb all the goodies from your diets, okay, and they're going to go through their own drainage system and back to what we call a hepatic portal vein. And where do they go next? Right, they go to the liver. Okay, and from the liver, they go all the way to the hepatic vein. So this is not a typo. This is two different type of vein. One is called a hepatic portal vein. This one after the liver, this is the hepatic vein. So make sure you don't confuse the two of them. This is not a typo. And from the hepatic vein, everything goes back into the inferior vena cava, right, and back to your heart. Now, here's the reason why we have to have this very difficult system. Why can't we just feed everything from your digestive tract and just put them straight into your heart? Why do we have to go through a portal system in this sense? Right. Think about it. What are the things that you eat? Probably something very good, right? All the goodies, nutritious stuff. So one thing is, if we put them to the liver, we can help store. So we can help them store fuels. For instance, you can put glucose that you absorb back into glycogen. And same thing, you can store triacylglycerol. You can store fats as well, etc. So one thing is they help us store very important fuels that came from your digestive tract. Now, the things that you eat, is it all good? Or sometimes you might be having something terrible and then you might undergo diarrhea, things like that. So this is also a very important reason. If you have any pathogens in here or terrible stuff that are toxic to your body, this is where we can detoxify. Okay, for detoxification of any substances. So, for instance, if it's any type of things, toxin that are very toxic for your body, in your liver, we have enzymes to actually help lessen these toxic effects of it. So then everything before, we'll make sure the blood is cleansed. If there's pathogens, we will destroy these pathogens. So as a result, whatever is coming out from your liver is going to be clean, good fuels. Okay. So then you can return it all the way back to the heart. So, because we don't want bad stuff to go straight from your digestive tract and all the way back to heart. That would be detrimental because afterwards it goes to the rest of your body. Okay. So very important to have this hepatic portal circulation. Now, our pulmonary circulation, which we have seen before, let's just do a quick review, involves when you have deoxygenated blood coming back to your heart, for instance, from your superior vena cava back to your right atrium, from your inferior vena cava back to your right atrium, as well as from your coronary sinus. So everything goes through your tricuspid valve and goes to your right ventricle, goes out into your pulmonary valve, into pulmonary trunk, and into the pulmonary artery. Remember, we say most arteries are red, but this is the blue one, okay, because they contain deoxygenated blood. And from both sides, yeah? So left pulmonary as well as the right pulmonary artery. So once they're back in the lungs, your lungs receive fresh oxygen and unload the CO2. So now everything is going to come back to the pulmonary veins, right? These are your red pulmonary veins containing oxygenated blood, packed with oxygen. So coming back into your left atrium, into your bicuspid valve, into your left ventricle, out into your aortic valve, and into the aorta. So make sure you know these are some exception. This is the place where you have arteries carrying deoxygenated blood and veins carrying oxygenated blood. Okay. Now, fetal circulation is very interesting because we were all little before in our mommy's womb. So how does a fetus receive oxygen, nutrients, and how do they remove waste? Right, they can't do everything on their own. So everything actually goes through the placenta. And with the help of specifically the umbilical cord as well, plus umbilical cord. So if you take a look over here, here is the placenta. Now we have one umbilical vein that's going towards the fetal heart. Okay, and we have two umbilical arteries that are returning away from the fetal heart. Okay, so this is also one exception, but this is before birth, where the umbilical vein carries oxygenated blood and the umbilical artery carrying deoxygenated blood. Okay. And technically, the fetal blood, as well as the mommy's maternal blood, they don't mix. Okay. But all the goodies from the mommies is going to be go through tissues of the placenta and into the fetal blood, but they don't mix at all. Okay, very important point to note it. Okay, now, so there are several changes that has to occur, for instance, during birth as well as after birth. Now, before birth, we have to pay attention to our lungs, because in our mommy's womb, your lungs are not functional, right? So technically, anything, for instance, that's pumped into your right atrium and into your right ventricle, supposedly we're going to go to the lungs, but this is not going to work because our lungs are not functional yet. Okay, lungs are not ready. So what do we do? So at that time, there are two very important structures. For instance, if you take a look over here, instead of going through the pulmonary trunk and into the lungs, we have a region that goes straight from the pulmonary trunk into the aorta. So this is what we call the ductus arteriosus. So this is going from pulmonary trunk into aorta. So that's why you're bypassing your lungs, because it's not working yet. Now, so that's one structure over here. Now, after birth, right, our lungs are working. They're happy and doing their job. So this becomes a fiber. And we call that, what do we call it? Right. So our ductus arteriosus becomes actually a ligament. Ligamentum arteriosum. Okay, so it becomes a fiber and then it stays right over there. Now we have another structure that helps us bypass our lungs. So right over here we have a hole so that the bloods go from your right atrium straight into your left atrium. So that hole is what we call here a foramen. Remember, foramen is a hole, and it's an oval-shaped hole. So foramen ovale. Now, so this is great because this is the second thing to bypass our lungs. Okay, and blood will feed straight into the left atrium and to the left ventricle and out into the aorta. So after birth, we can't have this hole anymore because our lungs are working. So this becomes a depression, not a hole anymore. So it becomes fossa ovalis. So it becomes a depression, not a hole. Now I just want to show you the other couple structures. We have our umbilical vein that we say going straight to the liver, the fetal liver. Now this becomes eventually just a ligament as well. Okay, and our umbilical arteries, okay, that we're draining back away from the fetal heart also becomes ligaments. Okay, so they become umbilical ligaments in a way. So, but definitely these first two changes, I want you to know about them. And here is the last few slides. So don't worry too much about it, but I just want to show you how we start from for our development of blood vessels and blood. So if you take a look over here we have our endoderm here, and in the middle is our mesoderm, and we have some angioblasts right inside. Okay, angioblasts. So anytime you see angio, it tells you it has to do with blood vessels. And these angioblasts are precursor cells. So pretty much all of our blood vessels and everything, they form from mesoderm. Okay. And from the mesoderm, you will see that we have these very specialized cells. Okay, the blood cells are in here. Some are also called hemangioblasts. Okay. So hema means blood, blast means immature cells, but eventually they will group into their own type of blood cells, angioblasts, for lining the endothelial, becoming the endothelial cells. And we also have our pluripotent stem cells, the hemocytoblasts becoming blood cells. Okay, so but only thing I want you to know is they came from the mesoderm, and eventually they work around their way around to become endothelial cells as well as the blood cells in them. As we age, as you probably notice, a lot of things changes with our cardiovascular system. So what do you think happened to the cardiac muscle fiber size? Would they be the same, doing much better, or probably weakening? Right, the probably sizes are going to shrink because unless you're maintaining a very healthy diet as well as healthy exercise regime. Now, what do you think happened to the output? The cardiac output is the amount or the volume that is being pumped out each time when your heart contracts. Right, your heart's working hard for a long time, so they may be pumping less. How about heart rate? Right, your heart rate may be slower. And how about systolic pressure? When your blood is contracting the most. This, on the opposite end, actually increases. And a lot of time is because your heart has to work harder, in general sense. As we get older, maybe there's more plaques formation, more fatty materials in the blood vessel, so making your heart has to work extra hard. And it's sometimes related to blood cholesterol level that is much higher than compared to when you're younger. So very important to take good care of your heart, because when you know how to take good care of your heart, you can help your family take care of their hearts as well. Okay, this is the end of chapter 1, and I'll see you in the next lecture.